My name is Mike Terrell. I'm a technology architect at 1E. Pretty involved in the community. Do a lot of speaking at user group and throughout the country and around the world as well. I run a user group myself, and that's a great way to exchange information. So if you guys are in a city that has one, definitely look it up. But I kind of do this for work, but also for a hobby as well. So you can follow me on Twitter. I try to talk a little bit about this BIOS to UEFI problem. This is not necessarily a BIOS to UEFI session. This is really preparing for getting to UEFI along with some of the pitfalls that you're going to encounter. But you need to do, a full assessment of your environment and how you can do that. So with that, it's going to start off kind of as a low 200 level session, and I apologize because I think they put it in as a 200. But we're going to ramp up and kind of go between 3 and 400 in some parts. So hopefully I don't lose too many of you if that's the case. But it'll really help you out in your environment to get started. So there's been a lot of buzz around UEFI. It's been out for quite a while. There is a UEFI consortium, basically, that publishes specifications. So most companies are still deploying devices in what I call legacy BIOS mode. And I'll kind of explain the terminology because some people say legacy BIOS, they'll use BIOS and UEFI interchangeably. But we'll kind of go through and define what we mean by each of those. There's 3 different classes of devices that are UEFI. Class 1 devices are the oldest. Those are mainly like servers. Class 2 devices are pretty much what we have out there in the enterprise today. So like this Dell that Keith has down here, that's a Class 2 UEFI device. And what that means is it can run legacy BIOS or emulated BIOS. It can also run UEFI with compatibility support module also. And it can run native UEFI. Now, typically, the vendors have been shipping devices in legacy BIOS for years and years and years. And there's a very good reason for that, because there are certain operating systems that don't support native UEFI. Now, the third type of device is, if anybody's got a Surface, there's a Surface up here, that's a Class 3 device. It only runs UEFI. So you might see newer equipment from Dell, Lenovo, or HP that are only UEFI devices. Those are Class 3 devices, meaning they won't run Windows 7 going forward. So there are some benefits to running UEFI. Basically, it's a replacement for BIOS. BIOS has been around since probably the early 70s. It's very limited in what it can do in terms of disk sizes. Disk sizes have grown significant over the years. Probably many of you thought like a 500 meg disk was huge long time back in the day. Now we're seeing easily 4 terabyte disks. Processor support, UEFI has native architecture for 32-bit or 64-bit, and there is a difference between UEFI devices that are specifically 32 or UEFI devices that are 64-bit. It can take advantage of all the RAM on the system, whereas the legacy BIOS can't. And then secure boot, we're going to get to that in a minute. And that's really one of the main drivers to getting to UEFI in the first place, is to be able to get to a secure state. BIOS does not support secure boot, as well as certain operating systems. So some of those operating systems that first supported UEFI start with actually Windows Vista SP1. Did anybody run Windows Vista? You guys are brave to admit it? Okay. But most people probably completely forgot about Vista until you just saw it on the slide. So Windows 7, if it's 64-bit, can actually run UEFI. Now, it needs a little bit of help, and it needs to run in what they call a compatibility support module. So I've adopted some terminology when we talk about that. and you'll hear me say UEFI hybrid. So when I say UEFI hybrid, I mean with CSM. Windows 8 and 8.1, that's native UEFI going forward on 32-bit as well as 64-bit. ARM support as well, but we don't see too many of those. Same with Server 2012. Now, when it comes to Windows 10, there's some nice documentation, and I have some resources in the slides in the very end that you can click through at the end of the session. But Windows 10 requires UEFI 2.3.1 errata C. So I haven't found a good way to actually report on that from the vendors of what flavor of UEFI it's running, but pretty much anything with a Windows 8 logoed sticker has the capability to run UEFI 2.3.1 errata C or newer. Now, the reason that's important is because it is a requirement to run Secure Boot on Windows 10. So that specification was actually published by the UEFI consortium in, I think it was the summer of 2012. So that's going to be a good kind of cutoff delineation when you guys do an assessment of your own environments of, all right, what can run Windows 10 Secure Boot and what cannot. So if your goal is to get to that state, then any devices that are older than that, you probably want to refresh because they're not worth your time to actually upgrade them. You can upgrade them, but you're not going to be able to take advantage of those security features. So some of the other benefits of running Windows 10 in UEFI mode are not only Secure Boot, but things like Device Guard and Credential Guard. So you probably heard of pass the hash. So with that is you can just pass the hash. If I can access that hash of your local administrator, I can pass that on and gain access to other things. If you use the same local administrator password throughout your network and that gets compromised, or I could just compromise it from passing the hash, I can move throughout your network just like I'm a domain administrator, basically. So it's really important that we want to be able to isolate those types of credentials and also randomize the local administrator password. If you do both of those things, then you're going to prevent certain types of malware from moving through your network like that. Now, Device Guard also secures the device in terms of what types of software can run. It's not going to let certain applications that you haven't approved to run on a specific device. Now, chances are you're not going to just go Monday, flip that on, because then users are likely not able to do their job if you haven't defined everything that should be able to run in your environment. But at least you can use it as a stepping stone. Once you're to UEFI, you can start evaluating that in your network and maybe start simple with kiosk type systems. Systems that are pretty much a known state that don't have users. Point of sale systems, definitely. You want to make sure you lock those down and secure those devices. Early launch anti-malware, that actually loads just as the operating system is loading. So it could check certificates to see if code is signed properly and nothing is infecting the system. So Windows Defender in Windows 10 is actually one of the few that do early launch anti-malware. I'm not sure what the third party's plans are for that, but that's another layer that you can use to secure those devices. Now, I talked a little bit about BIOS mode, and here's just a little screen scrape of MS Info or system information, and you can kind of see where it says BIOS mode at the top, UEFI. Now, that's available on Windows 10. I'm not sure about 8 or 8.1, but that's a quick check, and I'm going to show it. It also has other information like whether Secure Boot's enabled. So you can go to UEFI without actually enabling Secure Boot, and there's good reasons for that. So one of the user groups I was speaking to on a break, a guy came up to me and said, hey, we actually had an issue with some video card drivers. They weren't signed properly, and since those get loaded up as the operating system's loading, it was preventing those systems from booting up completely. So do your due diligence when you go to actually flip on Secure Boot. Make sure that you're baselining your driver versions, your firmware versions, everything across the board to a known configuration, because if you just automatically start turning things on, you might get some help desk calls out of it. All right, now it's time to pick on the vendors. So one of the HPs I have, it's a 9470M. It's one of my test systems. That's one of the devices that does have a little bit of issue, at least on the earlier Windows 1511 builds. When Secure Boot was on, Windows 10 setup didn't want to run properly. It kept blue screening on me. And I thought there was an issue with the image until I used just the native image, and it was still blue screening. And so just on a lark, I said, let me turn off Secure Boot and see if it boots up. Booted up fine, got through Windows 10 setup, was able to flip on Secure Boot at the very end, and it could be Secure Boot from there. So, you know, do your homework when it comes to Secure Boot as well. You want to get to that state because only signed bootloaders will actually be able to boot. So if you're using any kind of third-party bootloader, and we'll talk a little bit about Pixie in a little bit, but if you have Secure Boot enabled, they need to have a signed bootloader from Microsoft in order to boot. Otherwise, it won't boot up. How many are using Configuration Manager in this room? Okay, good. So there are certain things that we can do to get ready to do assessment of our environment, to see what state our devices are in when we get ready to go to Windows 10. The first way is you could do it via hardware refresh. That's really, you know, you're waiting for devices to fall off. We're going to go to UEFI over a period of 3, 4, 5 years as we go through device refreshes. Not the fastest way to get to UEFI, not the fastest way to get to Secure Boot or take advantage of some of these other advanced security features in Windows 10. And that's the whole point of moving to UEFI, is to take advantage of those features. You could also do it via break fix, and that's a good opportunity. You get a machine back, it needs to be reloaded. Let's reload it, let's send it out in UEFI. So that way we don't have to touch that device a second time. And I'll talk how Win 7 kind of comes into play there as well. In-place upgrade. Microsoft has done a fantastic job on the in-place upgrade scenario for Windows 10. The drawback to that is if you're a BIOS system and you do a Win 10 in-place upgrade, you're still a BIOS system. No UEFI. There's no easy conversion because it actually requires a different disk layout. And we'll go through the disk layouts in a minute, but it requires a full wipe and load of the disk. Basically, we're repartitioning the disk so that we can boot UEFI the way UEFI wants to boot. How many are still deploying Windows 7 x64? Just about everybody. Okay. Yeah, we'll get towards that. We'll get to that towards the end. So, what you can easily do today, and this is really kind of a vendor agnostic approach, and this is something I came up with about a year ago, a little over a year ago, was I was trying to think of a good way that we can inventory for UEFI in the environment without doing any additional steps, at least on the endpoints themselves. So I found a little registry key that actually corresponds to Secure Boot state. It tells you whether it's enabled or not enabled. So what you can do is you can actually edit your Configuration Manager hardware inventory by editing your configuration model first. So basically what that does is that uses the registry property provider so that we get this information into CM in a supported fashion. Then we can actually define those classes in our Config Manager console. Using the console, we define those particular classes, and then next we get Secure Boot state in Resource Explorer. It basically creates a new view in the database. We could use it for web reporting. We can use it for looking up Resource Explorer. If you're doing anything with Power BI for reporting in CM, you could access that view in Power BI as well. But this is a pretty simple way in terms of how I can turn it on, and after hardware inventories run in my environment, I get a good gauge of not only if Secure Boot's enabled or disabled. For those Win 7 devices, it doesn't use Secure Boot, it can't run Secure Boot. So that value is going to be null. So if we look at a simple pie chart, and this actually came from a Power BI that I created, we can see that implicitly we know that if that value doesn't exist, that's a BIOS running machine. If it's off, that's what the black represents, and if it's on, that's what the green represents. So very quickly I'm able to see, I've got a little less than half of my environment already at UEFI, and those 84, all we really need to do is flip on Secure Boot if we've validated that Secure Boot works in those scenarios. Now, the vendors have provided ways to get vendor-specific information into Configuration Manager. And we typically haven't had a need to pull that information in. But the previous method, it just shows, if it's running legacy BIOS. Let's see if it'll go back. So the red is if it's just running legacy BIOS, but that doesn't tell me whether those systems are capable of running UEFI or capable of running Secure Boot. So although this is good from a high level, and it gives you a good starting point, we want to figure out how many of those devices that fit in the red area are actually capable of running Secure Boot and UEFI 2.3.1. And this is where the vendors have made it possible to actually suck this information into Configuration Manager. So Configuration Manager's pretty much built on WMI. So they've extended WMI namespaces. We can collect those properties and inventory those, scoop them up via normal Configuration Manager hardware inventory. And then we can do the same kind of reporting on those as well. Now, in terms of the settings that we want to pay attention to, first and foremost is BIOS version and release date. I'm going to get to that in just a little bit, and there's good reasons for that. But those are natively inventoried by Configuration Manager. Boot mode is another one. Now, boot mode, to some vendors, means whether I'm booting UEFI hybrid, legacy BIOS, or UEFI native. Boot mode to other vendors means different things. And so there's differences across the vendors, but you want to see how that device is set up to boot. Now, I've talked about Secure Boot, but we also want to see if it's Secure Boot capable. Because if it's not Secure Boot capable, stick that in the refresh pile. That guy's the first one to get a device refresh when going to Windows 10. We don't even want to deal with that device anymore. How many of you Pixie boot in your environments today? Quite a few. So another thing that you need to consider when you're actually moving to UEFI is it uses a different network stack than legacy BIOS. So if you don't flip on what I call UEFI Pixie, you're going to be Pixie booting the legacy BIOS method, and that's not a good thing, and we'll get into that, why it's not a good thing in a little bit. Virtualization settings. In order to take advantage of device guard, credential guard, it requires Hyper-V. So Hyper-V requires the virtualization settings, Intel VTX, Intel VTD, so that's a good thing to pay attention to. TPM settings, for those of you that are using BitLocker or any other software applications that leverage the TPM. If you're using Wake on LAN, you might want to pay attention to that because we might have a different Wake on LAN order when we're now at UEFI. And then lastly, device boot order. So they also have different boot orders depending upon what mode they run in. Now, in a traditional sense, in a legacy BIOS, we'll see things like CD-ROM drive or USB or hard drive or network. But when we flip to UEFI, that boot device order changes. That boot list is completely separate from the other one. So we need to be cognizant of that when we actually switch a system over to UEFI. Lastly, some other important inventory items, not so much related to getting to UEFI, but things you want to plan for, pay attention to. OS architecture being one. Free disk space, definitely, because you want to make sure that you have enough free disk space if you're able to take advantage of the in-place upgrade, maybe on systems that are already running in UEFI mode, and then the additional TPM settings as well. So let's jump into each of the vendors, and they provide quite a few classes. You probably don't want to enable everything that they make available. You're going to bloat your configuration manager database. You want to grab just the necessary changes. So they do have their own namespaces. And for Dell, you actually need to deploy what they call Dell Command Monitor. And for those of you that run Dell shops for a while, that's just the new marketing name for what used to be known as OMCI. So OMCI is a little agent that you need to deploy out on your Dell systems, incorporate it in your OSD builds so that it gets installed by default, so that it'll actually create those, the Dell namespace and those classes so that we can scoop those up. Once you have that there, then you can extend your config manager inventory, and I'll actually show you what it looks like because I'm actually running a Dell up here right now. And like I said, you want to be very selective in what you add. If it's a lab, you can go gangbusters and you can select every class and property that they have, and when you're really bored, you can go through each one and see if there's any valuable pieces of information to you. Now, I will put out a disclaimer there. There is an issue with the latest version of Dell Command Monitor. If you deploy it to systems that are already running Hyper-V, maybe you've got a team of technical people that have Hyper-V enabled for VMs and things like that, it will break Hyper-V. Hopefully I'll get some downtime after this week to edit my blog that I have on setting up Dell Command Monitor as an application to deploy it using Configuration Manager, to where you can actually repair the WMI for Hyper-V, that it kind of overwrites those settings. It's not a drop-dead case. You can actually basically uninstall it, reinstall it. There's no need to do that. There's a simple moff comp that'll actually fix it. Dell does know about it. Who knows when it'll get fixed? They don't seem to refresh this this tool very often. I think this release is well over a year old already. But just be careful there. Always do your testing. I tend to test on coworkers when I can, and that's why they don't necessarily like me sometimes. So, come on. All right. Real quick, just a show of hand. I want to see how many people are running Dells in their environment today. Yeah. How about HP? How about Lenovo? Okay. Pretty even. And probably most of you run more than one, right? I'm guessing. Yeah. Okay. So you got to deal with multiple vendors. All right. So for HP, the thing I like about HP is they provide their namespace automatically. No agents need to be deployed. WinPE, I can boot up in WinPE, and after things have initialized, I can go into whether you're using Wimic or WebTest or anything to browse namespaces. Boom, it's all there. Nothing special needed. And that's huge because I like it when things are easy and they just work. They do a pretty good job too on the values that you can scoop up and read back into Configuration Manager. So we can get those things like possible values, for example. So remember, think secure boot in your back of your mind. You want to know if it's even a possible value that secure boot can be enabled or not. Lastly, and I'm just covering the main three because a majority of people use these three vendors. I know Microsoft is coming along with Surface Pros and Surface Books. There are some other vendors like Fujitsu and Panasonic, but those aren't very prevalent in the environments. Anyone using something other than these three vendors, just out of curiosity, a couple. I'm gonna pick on you. What do you?
We have Toshiba laptops.
Toshiba's, yeah, Toshiba's is another one, okay. All right, so let's get to Lenovo. Once again, Lenovo, just like HP, I don't need to do anything. They create that namespace automatically. Even in WinPE, I can boot up, I can browse to that namespace, and I can see settings. Now, there's fewer settings. It would be nice if they exposed more settings and they grouped them a little bit better, because I'll show you what that actually looks like when we switch into Configuration Manager. So now for some demos. All right, so for the first thing I want to show you guys is, this is just system information, MS Info 32. If you right-click, run it. Quick check, you want to see if the machine's running, if Secure Boot's enabled or not enabled, what the BIOS mode is, and that's why I call it BIOS mode. You know, you'll talk to Linux guys and they'll be like, it's not BIOS mode, it's UEFI. Well, no, actually Microsoft calls it BIOS mode. I'm using Windows, I call it BIOS mode, whether it's legacy BIOS or UEFI. So if we take a look at that, the other nice thing too is you can actually see the build number that's running right here. So this is the anniversary update. If we go down further here, we can see that this indeed is running UEFI and Secure Boot state is actually on here. Now some other things you're going to see further down here is your device guard settings. So we've got device guard virtualization-based security is actually running, and this is what it says when Hyper-V is actually installed. Right? That's messing up on me. When Hyper-V's been detected, right there. So just a quick check. If you ever come up to the device and you're looking for that information, pop it open really quickly, and that's where you can see it. Now, the setting that I was talking about in the registry actually happens to be in what we call HKey local machine system, current control set, control secure boot state. Now, don't worry about this because I have a blog out there that shows you how to do this. Download the text file, don't try to copy and paste. If you copy and paste into your configuration.mof and you get weird characters in there, your hardware inventory stops working. Not that it's happened to me, but yeah, always try to use text and don't get the special quotes and that kind of stuff. So from here, since I've got it enabled on my device, I can see that this is set UEFI secure boot enabled equals 1. So that's what we're going to scoop up with Configuration Manager, and we're going to see what that actually looks like. Now lastly on this machine here is I do have the agent running here, and for Dells, this goes on for pages, it seems like. Anything with the DCIM here is a Dell class. And the one that I have highlighted in the middle here is what we actually want to inventory. So feel free to browse through all those. You can dump all those settings out, see what applies to laptops. Same thing goes for servers too. So if you wanted to extend hardware inventory information on your servers, you could do that as well. But what we're looking for is DCIM BIOS enumeration. Now, if we click on that and we look at the instances, it's going to dump out all those settings that we're looking at. Now, this looks a little bit ugly. I give you that. But we're going to let Config Manager suck it in and make it look all pretty for us. So with that, let's shift over to Configuration Manager here. And the first thing that we want to look at on this guy, and I'm just going to point this out because I'm going to talk about this next once we flip back into the slides. PC BIOS is already enabled in the hardware inventory. Now this happens to be on my HP system here, but we look at the BIOS version, and this is key here. Now I'm gonna give you guys a test in a little bit, and I'm gonna ask you to repeat what that BIOS version is. But that's an ugly looking string value, and it's hard to do comparison on string values. So notice that release date is also listed in here. Much easier to do comparisons on release dates also. So just keep that in the back of your mind for now. Now if we look at the secure boot state on this, we see that, let me see if I can get that up as high as possible. So we see down here, by extending the hardware inventory, we get a new node in Resource Explorer called Secure Boot State. And on this one, actually there is no value because this machine happened to be running BIOS at the time. So that registry key doesn't exist. Plain and simple. Like I said, quick, easy test. It doesn't tell me whether this thing is capable of running Secure Boot or not. But I can actually use this to do reporting, or if you create collections and use queries, you can query on devices, and as they have Secure Boot either enabled or disabled, maybe we want to have a collection where we target a settings management policy to it that says if Secure Boot's disabled, let's enable it. Somebody that has local admin rights went in and turned it off. Let's go ahead and turn it back on. Now for HP, these guys, I have two classes in here that I've actually inventoried. The actual BIOS settings themselves, as well as the BIOS ordered list, and that's really the boot list. So real quick, I'm going to sort on this before I zoom in, because the first thing we want to look at is secure boot state. Now you'll notice that HP gives us really nice, clean looking values like current value, whether we display it in the UI. And the UI to them means when I hit F12 and I go into the HP BIOS, I'm actually going to see that setting in there. I can see if it's read-only, I can see what the name of it is, and I can also see the possible values also. So for secure boot state, we can see that the current value is set to disabled on this device, but we could see that the possible values are disabled and enabled. So this device definitely supports enabling secure boot. So right there, now we know that this device is good. We can do a wipe and load on it to get it up to a UEFI box and then enable secure boot on it. Now I scrolled down just a little too much, so let me zoom out really quickly. But we talked about the PXE settings. So most of the vendors talk about IPv4 NIC boot, IPv6 NIC boot. So that's what I call UEFI PXE. So we want to actually enable that once we flip a device to UEFI so that we can UEFI PXE boot, so that Config Manager will format our disk appropriately so that we can continue to run in UEFI mode. So like I said, there's lots of settings in here. And when you're bored or you have insomnia, you can peruse through all the settings and see what you actually want to do. But this just gives you some ideas, because then you can do some really clever reporting, and you can come back to your, whether you're the CM infrastructure guy and you got a desktop guy bugging you for inventory lists, you can give him a rich set of data or create web reports. Here's the web report I created for you. Go look it up yourself, that kind of thing. So now in terms of the BIOS ordered list, we talked about two different boot orders. So we've got, in terms of HP, we've got a legacy boot order and we got a UEFI boot order. Boot orders are interesting because DeviceGuard either requires or recommends that you only have Windows Boot Manager listed in the boot order list. And the reason for that is we want to secure that device, And I don't want anybody to be able to get access to the device, plug in a USB key, boot off that USB key, and now I'm going to start hacking away at maybe BitLocker or anything else and get access to that data. So think of it as an extra layer of security. You'll probably get your security guy who might think he's smart and he poke holes in BitLocker because he just doesn't like it because it's from Microsoft, and he wants you to use some third-party disk encryption that doesn't play well with systems management. It doesn't play well with OSD. It causes you headaches. You can't patch systems. But you can use BitLocker with extra layers of security, or anything for that matter, as long as you're securing that device, locking it down. That's several steps that somebody has to go through to actually be able to access data on that machine. And I kind of think about it as each of those layers are like a lock on your backyard gate. I have a lock on my backyard gate. My neighbor doesn't. So if somebody's going to come steal something out of the backyard, is he going to waste his time hopping my fence, which is 6 feet, or is he just going to go in through the neighbor? Now, he could cut it, but it is an extra security measure, just like your UEFI boot order. And once again, like I said, the boot order has changed. So under legacy BIOS, you could see here that it said notebook hard drive. Well, in this case, now if I just switched it to UEFI, but I didn't change the boot order of the devices, well, that thing's going to pixie boot every time, first. And if you got a mandatory Pixie server out there that's replying to request, or worse yet, you get a malicious Pixie server out there that replies to requests, guess what? You just completely reinstalled your device because your Pixie boot order is set to first. So things like that, when you switch to UEFI, make sure you go through all these settings and see how they're going to play in your environment. Now let's take a look at Dell, see what Dell looks like. So Dell, same thing here. And let me see if I can go down to the secure boot settings. Now actually what I wanted to show you too was boot mode, and I didn't show that to you on the HP. So I've kind of adopted the HP language in terms of whether we're, actually let me just go back to that really quickly because that's actually kind of important. And you got to resort it every time. So boot mode, and this makes the most sense to me. We talked about legacy, which is legacy BIOS or legacy BIOS emulation. We talked about UEFI native, which is what we need in order to run secure boot. And we also talked about UEFI hybrid. So it says with CSM. So CSM is an industry term for compatibility support module. And that's what HP calls UEFI hybrid. So I like the terminology because if you know the definitions, then you know exactly what somebody's talking, and there's good reason for it. Compatibility support module and secure boot don't mix. If the CSM is enabled, it cannot enable secure boot. If secure boot's enabled, you cannot enable the CSM. Also, another point to note is you can programmatically enable secure boot. That's part of the spec, but you cannot programmatically disable secure boot. Because if I can gain access to your machine, I can be malicious, I can disable secure boot on it, and you kind of defeated the whole point of secure booting in the first place. So when you go to test this in your own labs and you want to reset your tests, you need to actually boot back up and physically say secure boot disabled. Question?
Is it kind of a generic requirement that you apply a password to enable secure boot to your BIOS? HP is requiring this basically, maybe it's the TPM chip. You got to assign a BIOS password.
Yep, so the question was, do I need to assign a BIOS password in order to enable secure boot? And the answer is no, but it is the TPM. So if you want to get the TPM going, you need to have a BIOS password for it, just an extra security layer. So I need to set a BIOS password in order to enable and activate the TPM.
That'll take back off every course.
Yep, and little secret, on Dells you can actually enable it to something, turn that TPM on, activate it, and then disable it as well. But while we're on the topic of BIOS passwords, I find BIOS passwords equally important. It's another security layer. And just like local administrator passwords, actually just a quick show of hands. Who's not using BIOS passwords today? About 40%, okay. Who uses the same BIOS password on all their machines? Okay. So that's kind of similar, once that BIOS password gets out, I can get into your machine and access it, and you probably use the same local administrator password too, so then I can get into that as well, and I guess it's kind of like the lock on the gate where I could just clip it off real quick, but yeah. Who randomizes BIOS passwords, just out of curiosity? Anybody do that? Three people. Okay, you guys get an A+. I'd like to understand how you guys are actually doing it too. Whether you're using some kind of lookups or you're doing some kind of encryption algorithm based on SMBIOS, GUIDs, or something like that. But that's a good approach. That's a good security model to get to because nobody's going to get into that device. All right, so let's switch gears real quick and look at what were we looking at? We were looking at the Dell. Okay. So Dell, same thing. They give us some rich information, and I'm just going to slide that over. So for boot mode, we can see that this one can boot UEFI. If I zoom back out and find secure boot, you never can find this when you got a room full of people staring at you, but we can see that this supports being enabled here. Now, Dell likes to be a little bit different than everybody else when it comes to compatibility support module. They thought they'd be cool and call it the legacy OROM. So if you do look for CSM in here, you're not going to find it. But if you look for legacy option ROMs, I believe it is, or option ROMs, and I'm definitely not seeing it here, right here, enable legacy option ROMs. So they don't combine that with boot mode like HP does. So just keep that in mind when you go to flip things. You need to set it to UEFI and then turn off the legacy option ROMs or the CSM before you actually enable secure boot. All right, lastly, before we go back, let's look at Lenovo. Now, Lenovo, I give these guys, I give them an A+ for the vision. I think they got a little bit of catch up to do in terms of kind of dividing things up into the fields properly so that we can actually report on them a little bit better. They just kind of like to munge everything together. So if we're actually looking at secure boot state here, it's all in the same field. So when you need to do your queries, or your SQL queries, or your collection queries, you need to figure out how to handle that and split it up and look for the equals, that kind of thing. So it would be nice if they put possible value as well as current value, and kind of divided all that up. But currently that's not the case. So, but you get the same kind of information out of here in terms of your network boot, your UEFI Pixie boot priority as well. So, all right, so let's switch back over here. Clicker. All right, so let's talk about booting UEFI. What requires booting UEFI? Now, this is the thing that gets people when they try to convert to UEFI in a zero-touch process, is the disk layout for legacy, we call it MBR. Unfortunately, MBR is susceptible to bootkits and rootkits and other bad things that you hope that you see in the news that people get hacked, and you hope that it never happens to you, but that happens. So that's part of the problem is we need to get to a disk partitioning scheme, clicker's a little slow, called UEFI, or GPT. So GPT actually has a different partitioning layout. Now, at the moment, there is no supported method to convert an MBR formatted disk to GPT for the system disk. You will find utilities out there if you search on the internet. I wouldn't even bother trying it because the minute something goes wrong and you call into Microsoft, they're not going to support you. They're going to tell you to completely reload that system. So this is a destructive process getting to UEFI. And that's what's got everybody kind of in a little bit of a bind here. We want to get to Windows 10. You got your security folks saying, no, we need to be able to take advantage of these security features and secure boot. And you're saying, wow, you just created a lot of work for me. But we can actually do that, and we can get to there. It's not easy. Now, we talked about booting UEFI for Pixie booting, or actually booting first. Has anybody ever tried to boot like a Surface device with a 32-bit boot image, or maybe a Gen 2 Hyper-V VM with a 32-bit boot image? It doesn't work so well, right? It gives you a little stop code. That's because you've got to boot your native architecture. If you don't boot your native architecture, yeah, that's a bad thing. Now, the other bad thing too is it used to be a rule of thumb to use x86 boot image as kind of the common denominator across your devices because, hey, that works great for deploying x86 Windows 7 and x64 Windows 7, right? Yeah, it doesn't work so well when trying to do that for UEFI. So if your task sequence is only deploying a 64-bit OS, make the switch now to 64-bit boot images. Configuration Manager also has some other challenges. If you actually happen to have multiple deployments, it's going to return a boot image that's associated with that last deployment, and it might be a 32-bit boot image. And if your device is already flipped to UEFI, it's not going to work so well. So there's another interesting thing called the client architecture type. So if you actually look at the client architecture types, we can see that there's different DHCP scope options. So these scope options basically will tell you what we can boot. Now, the most common one is if you're running in BIOS mode, it's going to show up as a 0-type Intel x86 PC. So that could be a 64-bit system, it could be a 32-bit system, and that's kind of why I put a yellow checkbox next to the x64 boot image. Yeah, your Dell laptop here, this one, it's a class 2 UEFI device. It can boot either one when it's in legacy mode. But once we flip it to UEFI mode, it's a 64-bit, an EFI BC device. So it's only going to work with the 64-bit boot image. Now, EFI IA32, Dell had released, I think they were Venue 8 Pros. Those were actually UEFI devices. Those were 32-bit UEFI devices. So you don't see a whole lot of those, or at least I haven't come across a lot of them, but I do have one of those, and that will only boot a 32-bit boot image. So yeah, and I'm just highlighting that's going to be the most common boot when you actually flip your environment over to UEFI is going to be the Type 7. So you see this little thing called DHCP option 93. Now, for those of you that like to get out your network sniffers and make enemies with your network team and they send off red flags, if you're actually sniffing a Pixie boot, you'll notice that you'll see that option 93 right here, and it shows us that this is an EFI BC machine. So I know that can only boot 64-bit. So if you do a capture with Wireshark or something like that and filter on your DHCP traffic, you'll actually see that option show up. So All right, booting UEFI with Configuration Manager. Now, we pretty much know the differences between BIOS and UEFI native, but there's always that in between, the UEFI hybrid. Now, I've seen on some devices, even though it might be running UEFI hybrid, it might still present me the option to legacy Pixie boot or UEFI Pixie boot. Now, that's important to note too for your technicians, because if you have devices that are in that state, you want to make sure that they're actually UEFI Pixie booting if your intent is to make that device a UEFI device and format that with GPT disk partitioning scheme. So what Configuration Manager is going to look at is a little variable called underscore SMSTS boot UEFI. That gets set depending on how that device was booted up. And as of 1606, that variable actually doesn't re-enumerate throughout the process. I don't know if they changed it in the upcoming release, but when it boots up, it uses that for conditions going forward. So typically on a native config manager task sequence, you'll see two format and partition disk steps, one for BIOS, one for UEFI. Now, also make sure that when you do flip to UEFI that make this the boot disk. If you don't, it's not going to be a bootable disk, and it's not going to work once it reboots. But part of this is there's a condition on here, and we can see that that last variable right here, if it's not equal true, we're going to format that for BIOS. If it is, come on. Batteries must be getting low in this guy. And if it is set to true, we're going to format it for UEFI. So make sure you can do that. Now, I guess what you could do is you could just put a condition in the start of the task sequence that says, if I haven't booted UEFI, just exit out and be done with it. Pull that BIOS step out completely if you're not going to be deploying that same task sequence to any BIOS type machines. So, all right, upgrading the BIOS/UEFI. This is important. How many of you guys flash your BIOSes today to machines that are already deployed out in the field? I'd say about 2%. Okay. How many of you flash them when they come back in for a break fix or when you're initially deploying them? Always check. Okay. That's better. When you're switching to Windows 10, there's good reason for doing so. First and foremost is you'll see something from the vendors. So this is an example. If you look through, if you're bored again on a Friday night and you look through the release notes of the BIOS release notes, you'll actually see in there where the vendor has added what they call added Windows 10 support. What this doesn't mean is if you're below that version, Windows 10 is not going to work. What it does mean, if you have issues and you call Lenovo, they're going to say, are you running the latest BIOS? Just like Microsoft with security patches and things like that, is they don't have time to go back and back test all those previous versions. That's what they first started testing Windows 10 against, and we said, okay, we validated it, that it works. This is what we're supporting going forward. Firmware fixes. You can see down here that we've got, you'll have regular fixes. You'll see that you got security fixes in here. So that's another good reason, right? Because the whole point of getting to UEFI is to become more secure in the first place. And if I've got vulnerabilities in the firmware or BIOS or UEFI, well, that's not a good thing. So we want to make sure that we're secure at that layer as well. And then lastly, vendor tools and utilities. So you can programmatically change these BIOS settings. It's been our experience that sometimes it works, sometimes it doesn't work. And when it doesn't work and you flash it, then all of a sudden it magically starts working. So there'll be fixes in there for that as well. So if you plan on using those vendor utilities and tools, you want to make sure you're flashing the BIOS too to have the best experience and known experience. Now, what are some of the tips, tricks, and pitfalls? Go by release date. And the reason for that is, and whoever can remember what that version of the HP BIOS was, I can't, but if you're trying to compare that to string values, how can I compare two string values? It gets really messy and I gotta figure out which one's greater than the other one. It's just bad news, right? So what I've started doing is actually going by the release date, because I can easily compare release dates. Now you might say, well, just put it in there as equals. If it doesn't equal blah, 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 F, whatever it was, 52 or 62, then flash it. Well, what happens if he's running F62? And that happens to be a release that has security fixes in. Well, the vendor prevents what they call backflashing. So I can't backflash anymore to an earlier version. So we do need to do a comparative, and the easiest way to do it is by the release date. So some newer releases prevent backflashing, those ones that have the security fixes in there. Use the configuration manager task sequence. Some of the vendors provide tools to do it. Some of those tools actually go across your network. If you've got good networks, great. Some of them go out to the internet. If you like your devices going out to the internet, great. If you like more control, use a config manager task sequence. Make sure you download the version that's certified for your environment that you've done your testing against. So it's kind of like total chaos or versus control when it comes to drivers, right? You want that known predictability state, because if it's going out to the internet, it's probably grabbing the latest, and if you didn't vet it out and test it, maybe it breaks something, I don't know. Suspend BitLocker or else. Anybody try to flash the BIOS with BitLocker enabled? Yeah, it asks for the recovery key, right, on the reboot. Yeah, not a good thing. So suspend that. The Dell guys, for all you Dell guys out there, if you read a KB that they have, they say to flash this device that's running in UEFI mode, boot up, change it to legacy BIOS, then boot with your 32-bit boot image, because we can't boot a 64-bit boot image, flash it, reboot, change it back to UEFI, and then boot up again. Now, it will flash in full Windows, because we do have 32-bit support, or WoW 6432, but if you're doing bare metal deployments, and I'm booting up into Windows PE, and I'm already UEFI, I can't flash my BIOS at that time. I brought it up to them. You guys can bring it up to them and say, hey, give us a 64-bit flash utility. Both HP and Lenovo do have 64-bit flash utilities. So a little tip there. I'm pretty sure it's definitely for the HPs. I'm not sure about the Lenovos, because I probably already enabled WinPE HTA. So that's not enabled on default config manager boot images. Add that in. The utility doesn't like to run without it for some reason. BIOS and hard drive passwords. That's another thing. If you're trying to automate it, you want to do it in the middle of the night, well, and you got a BIOS password on it, it's going to be stuck at that BIOS password. The user's going to come in and maybe try to power it off and power it back on. It might still be flashing. They might turn it off while it's still flashing, which might brick the machine. Not a good thing. So for those of you that do have passwords on there, make sure you disable those passwords if you're going to automate that. I'm always a big fan of testing the process. Test it again and again and again. You know, pick one guy, test it on him, and test it on him. And if you manage to break 3 of them, yeah, rethink that process before you flip the switch. Otherwise, you're going to have to polish your resume. So, and baseline and document your standards too. So whatever your release cadence is, maybe you review your BIOS versions every 6 months, which might be good enough, every quarter. Just document that and test it, and then you can actually run that against your environment to see how much BIOS fragmentation you have throughout your network. All right, enabling UEFI. All right, let's go to a demo, and my screen has locked again. It's called an overly aggressive screen lock timeout. All right, so usually I travel with a whole bunch of devices, The problem is these switches, they don't like to show low-level output, meaning BIOS screens, for some reason. So the easier thing was to take a bunch of screenshots of certain BIOS screens, and I'm going to try to roll right through these because I know we're coming up on time, and you guys are antsy for the beer in the expo hall. So if we look at, this happens to be on a Dell. Now, the Dells pretty much look consistently across all the Dells. So you're probably familiar with this if you've ever gone in there. But we can see on this particular screen here, and let me just get those screens off of there. We can see that this is you can see the legacy boot sequence, and this is set for legacy. So we can see things like diskette drive. I don't even think the thing had a diskette drive in it. So that changes when we go to UEFI. Here's that little setting that they like to call legacy option ROMs, which most of everybody else knows as the compatibility support module. So that's what that setting corresponds to when you're doing that inventory. If we look at the boot sequence for Windows Boot Manager here, it looks quite a bit different when we're in native UEFI. That's what we want it to look like. Unless we're PXE booting, then we want the UEFI PXE boot to show up below Windows Boot Manager. Now, if you've reinstalled Windows a few times in UEFI, you might go in there and you see a whole bunch of Windows Boot Managers. Well, when you try to boot up, your machine starts booting slow, and you're like, why is it slow? It's a SSD. You want to clean up those other entries. So I believe Keith has a blog out there on actually how to clean up all those extra stale Windows Boot Manager entries that no longer exist anymore. So. All right, so this is where we have what we call UEFI network stack, or I call UEFI PXE. The one below it is the legacy one. The one above it happens to be UEFI. Two different network stacks. So keep that in mind, since we did have a lot of PXE users out there. Secure root, once again, this is where you can enable and disable it. Like I said, you can programmatically enable it. When you reset your test, you got to come back in here and disable it. So you can't disable that. Now I know some of the Lenovo, I believe it was desktops, had an issue with actually enabling it. But check the latest firmware, because that's now been fixed where you can actually programmatically enable it as well. Another good reason to get on the latest versions. Here's the virtualization settings. Now the nice thing about these is they can be enabled after the fact. It's not a destructive process, so if you're not looking to go to device guard and credential guard right away or enable the hypervisor, you don't need to mess with these, but if you want to take advantage of them and light them up while you're doing your BIOS changes, these will need to be enabled in order to do that. Now, this is a little bit older HP. I know HP has some different variations in BIOS, and we can kind of see these are the same settings that we actually inventoried with Config Manager. So we've got our boot mode setting here, where they combine the CSM and the boot mode in the same option. Here's the legacy boot order that's highlighted, and I think I had the UEFI boot order right below here. So you can see two different boot orders that we need to pay attention to once again. Chances are you're going to want to clean up that list and dump as many things as you can, like USB hard drive or SD card. And that would be a hacker's dream, to be able to plop a SD card in and boot off of it, All right, so we showed UEFI hybrid with CSM, and I'm going to rip through these. Here's secure boot. I'm not going to zoom in. I did post a bunch of these to my blog, so if you wanted to do some documentation, you don't have a method to do some screen capturing, things like that. This is a ThinkPad setup, and actually what I really like doing is showing the ThinkPad setup on my Dell, and then people come up and look at the ThinkPad setup, and and a Dell, and it just kind of, see if they're paying attention, you know. UEFI legacy boot, this is where we can set it. In terms of supporting both, I don't really understand the use case for it. I guess if I had to boot 32-bit, but we don't really need to do that to flash it, so if you know, let me know, because I can't think of why that feature is there. So here's the CSM support for the Lenovos, and here's the boot priority for them. And secure boot state. UEFI Pixie, you can tell which one you want to boot first. IPv6 is really slow. So if you don't have IPv6 in your environment, maybe you don't want to enable that in the network stack and just have IPv4, because it will time out and then go to the next one, and then eventually time out and go to the next one if they're top in the boot order. So here's their VTX and VTD settings, and that's it for that. So I know I ripped through that pretty quickly, but we're coming up on the end of the time, so I just wanted to get through a few more of these slides before you guys jet out of here. There are vendor tools to do this, okay? HP and Dell, they provide a tool to do it. Lenovo, they expose their methods in WMI. So if you're a programmer or you're good at using WMI methods or WMIC, you can set those programmatically that way. The thing to note about these are, if you're trying to set a bunch of them, you need to be careful in what order you set them in. Because if I try to enable UEFI Pixie before I enable UEFI, the tool's going to say, hey, I was successful. And then enable UEFI, and then reboot it, and go into the BIOS and see if UEFI Pixie was enabled. Chances are it won't, because the order of operations does matter. So these are documented. The other thing I'll say is you'll find inconsistencies in settings, even within the vendor. On some platforms, it might be boot mode. Other platforms, it might be boot space mode. So they allow you to do, you can create answer files for specific models, but then now you're in the business of creating a ton of answer files and managing all those answer files. But you can call them native commands. But then chances are you're going to have different bat files, or you're going to have to put some logic in there, or you're going to have to do something else. Lastly, Lenovo uses, they have some VB script examples to do it. I think there's some PowerShell script examples. If you put PowerShell in your WinPE, it does bloat it because it has a .NET in there. But they don't expose all the methods, which I would like to see them do, so that we can get to UEFI on at least the ThinkPads. The only way to get to UEFI is to enable secure boot. We can't programmatically get to UEFI hybrid right now unless you know of a better way. But that's where we're at with that. So now, where to begin? First thing you want to do, determine what models are in your environment. Which ones will run Windows 10? Which ones are actually supported by the vendor for Windows 10? Because works doesn't always mean that it's supported. So if the vendor hasn't stamped their sign of approval saying, yes, we've tested this device and we support Windows 10 on it, it doesn't mean it's supported. It goes in that refresh bucket. Just refresh it. Are your models in a ready state? Are they configured correctly? Meaning, are all those BIOS settings exactly the way we need it so that it is going to get formatted for GPT and we'll be able to install it that way? Once you've done all that, you should be able to come up with a nice pie chart like this. So if you happen to deploy a lot of Win 7 or Win 8 devices already in UEFI, you might be able to take advantage of the Win 10 in-place upgrade because those devices are already UEFI. If not, maybe we're wipe and loading these devices, and up here, these are the ones that don't even support it, so we're throwing those in the refresh bucket. So depending on your refresh cycle, it might be every 3 years, 4 years, 5 years. That bucket might get bigger and bigger if it's a long cycle. And at the very top, maybe not ready. Maybe it doesn't have enough RAM. If you want to take advantage of those advanced security features in Windows 10, x64 requires 2 gigs of RAM, but if you want the advanced security features, it requires hypervisor, you want 4 gigs, and only give them your users 4 gigs if you really dislike them. I would set 8 as a minimum standard in my environment to make your users happy and give them a decent experience. So, all right. Is anybody deploying Windows 7 x64 in UEFI mode today? 1, 2, 3. It was like 4.5. The guy kind of had a half hand up. 5.5. We'll count that. How many of you knew that you could deploy Windows 7 in UEFI mode? All right, you guys have no excuses. For the others that didn't raise their hand, you can deploy it. It requires the UEFI hybrid that I talked about, so the compatibility support module. I talked earlier about CSM and Secure Boot don't mix. But this actually enables you to get to that easy Win 10 in-place upgrade that Microsoft talks about so much and says, oh, that's the fastest way to Windows 10. It is, but we want to be able to take advantage of the security features. So if you haven't started deploying yet, start converting it now. It's 100% supported. I actually sent this tweet out in March, and I said, if you still deploy Win 10 x64, do yourself a favor and deploy it in UEFI mode. That way you can upgrade securely to Windows 10 and thank me later. So all you need to do is flip off the CSM, enable Secure Boot, and now we're at a secure Win 10 state. Those of you might have attended Michael Niehouse's sessions earlier, but this was on an email distribution list that he sent out. I did get his permission to put it on here, but he's talking about the don't bother approach of not doing it now. You're just creating yourself more work in the future. So if you can deploy Win 7 in UEFI, then we don't need to off the user data and bring it back, have a high-touch process. You're still going to have to deal with things like application mapping, because maybe on Windows 7 our standard was Office 2013, and we want to upgrade that to Office 365 on Windows 10. Same for like Visio and other things. So remember, in-place upgrade just upgrades the OS. Your applications are still going to be down level if you haven't uplifted them as well. So, in summary, challenges. Converting in a single configuration manager task sequence, it's tricky. Config manager doesn't like to reboot. They've talked about putting some changes to make that easier, but you still have to do your OEM tool settings. It can be done, and come talk to me afterwards if you want to learn more. Switching BIOS settings needs to be done in a specific order. We talked a little bit about that, not getting set up right. And then lastly, it's a destructive process. So also if you're using x86 or any of the other things, you're not going to be able to take advantage of that in-place upgrade. Chances are that's running BIOS mode anyway. So that's that. I got a ton of resources in the end slide here. A ton of them linked to my blogs. I got a lot of how-tos out there on how to do all that inventory stuff to get that into Configure Manager, help you out today. Like I said earlier, I work for 1E. We've done a lot of on-demand Windows 10 webinars on the advanced security features, getting to UEFI, taking advantage of things like Credential Guard, Device Guard, how to plan and prepare for that. We could easily cover the rest of the day on some of this stuff. It goes really deep. So here's all the resources at the end. And thanks again for your time on the third day of the conference. I hope you guys have a great conference.